Now question 3 part 1, you are given a parametric equation, x equals to a cos cube theta and y equals to a sine cube theta, such that a is greater than 0 and theta is between 0 and pi. Now you are asked to express this in the form of Cartesian equation. And also to sketch the graph. Now in fact, they ask you to sketch the graph first and then express it in Cartesian equation. Now I shall touch a bit on the concept of parametric equations because some students are rather confused. Now the concept is very simple. X is related to theta and y is related to theta. So x therefore, or y is therefore is related to x. Now it is just that simple. Now if you key into your GC to have the sketch, now you must make sure the windows settings for your x and y is large enough, because sometimes if it's too small you may not see the graph. Not only that, now your theta, sometimes it's the form of t, it could be in other form of other letters, alpha or whatever. Now you must key in the range of theta. Now if theta is a set of real numbers, all right, make sure you set your theta to be, the range to be huge. Now if you set it too small, or you may not be able to see the graph, all right. If you set take for example, the range of x and y too small, your theta, you set it too small, you may not be able to see it. Make sure your range is huge enough. So how huge is huge? So x and y, maybe you can set from minus 200 to 200. Okay, this is just my suggestion. You can even set it bigger. Okay, then theta, if it's given a range, you just follow. All right, otherwise you set it to be huge. Right, it's just that simple. Now we shall now come to the question. Now sketch the graph. So very simple. You set your GC and make sure it's in the parametric mode. All right, key in your range of values of theta as well. If you are using the TI-84, your theta is represented by the letter T. Now you realize that there's a variable a here. Now, so sometimes we can cheat a little bit. We can assign a number to a. Maybe, let's say you key in the GC, let's say a is 2, all right, and then we look at how your graph will look like. So we suspect where it cuts the x-axis is a, all right, because we key in the value as a is 2, but this is what we suspect because this is how your graph looks like. Now, so these are where it cuts the x and y axis. Now to verify that is very simple. Now you just, for where it cuts the x-axis, all right, x-intercept, for x-intercept, y is 0. Okay. Now, so you use equation 2. So you got 0 is equals to a sine cube theta. Okay, so sine, so you got a is not 0, so you divide by a on both sides. So you got sine cube theta equals to 0. So theta will be equals to 0 and pi. So your value of x will be a. Alright, when theta is equals to 0 or pi. Now, how about the y-intercept? Y-intercept x is equals to 0. So you got 0 is equals to a cos cube theta. A is greater than 0, so cos cube theta equals to 0. Theta equals to pi over 2. Now when theta is equals to pi over 2, what is your value of y? Y will be equals to a sine cube pi over 2. Pi over 2 is 1, so your a is equals to 1 when y will be equals to a when x equals to 0. Question 3, part 1, you are also asked to provide the Cartesian equation with the given parametric parameters. Now, so for if it involves trigo, one of the common things that we do is we use this identity, cos squared theta plus sine squared theta equals to 1. Now this is one of the technique, alright. It's not always applicable, so you have to look at your equation, alright, but this is quite common, so you should know. So you express equation 1 in terms of cos theta. So cos theta will be equals to x over a to the power of 1/3. Alright, this is from 1. Sin theta will be equals to y over a to the power of 1/3, and that is 2. So if you apply your identity, alright, you will have x over a to the power of 2/3 plus y over a to the power of 2/3 equals to 1. Okay, you can just leave your equation like that, or you can times a to the power of, a cube on left and right. But my suggestion is just leave it, because with that you really get full marks. Okay. Now for that we move on to part 2 of the question. You have come to question 3 part 2. Now you are given a parametric equation x is equals to t squared minus 4 and y equals to 3t to the power of 4 plus 8t cubed such that t is greater than 0. You are asked to provide a sketch and also express it in the form of Cartesian equation. Now this is to provide the sketch is very simple. You set your GC to parametric mode and then just key in the given equation. Make sure your window setting is huge. Now, so how will the graph looks like if you key it into the calculator? Now you will notice that there's one graph that goes something like that, and then there's also another one, but it actually belongs to the same graph that goes like that. Now this value here where it cuts the y-axis is 122, this is 28 out of 9. You may get it in decimal if you are using your GC to read off where it cuts the x-axis and y-axis. And this part is minus 60. Now to express it in a form of Cartesian equation, you look at these two equations. Now, what do you have? If you express x in terms of t, then you can substitute into a y and then you can get rid of the t, all right? Then your equation will be in the form of x and y only. So let's do that. So x is equals to t squared minus 4. T will be equals to x plus 4 plus minus to the power of half. Now when you do a square root, you will get a plus minus, all right? Make sure you do that because otherwise you cannot get part of the graph. So y will be equals to 3 because this is positive and negative, but if you to the power of 4, which is an even, and then you only left with the positive. Now when you do a cube, all right, the negative will remains negative and the positive will remains positive. So you have a plus minus 8 t plus 4 to the power of 3 over 2. Now you have a plus minus here, okay? Now if you key it separately into your GC, all right, let's say you key graph 1 as, now you set it into Cartesian, all right? Now you see what happened, all right? You key this part and then you key this part plus, and your y2 you key it as this portion minus, all right? You will get true graph, and this one belongs to this. And this belongs to this. Okay? With that, we have completed question 3. Thank you very much.